Welcome to episode one of the SoothSight series. My name is Christopher Dole, and I co-founded Soothsayer Analytics back in 2014. I'm joined today by my longtime friend and colleague, Akshay Deshpande. The focus is on understanding what data science is and how to think about problems.
Hey, hi everyone. Hi Chris. As you said, I'm Akshay. I'm a senior director of data science at Soothsayer, and my background is in control systems in terms of education, and then I got into data science. I was fascinated by machine learning, and then over the past 10, 12 years, I've been working, with companies like IBM, and then for the longest time with Soothsayer in designing, architecting, and deploying AI-based solutions to solve a variety of problems.
So Darwin said, a mathematician is a blind man in a dark room looking for a black cat which isn't there. How do you ensure that you're asking the right questions when beginning an analytical endeavor?
Yeah, this is really critical, and I've seen a lot of initiatives kind of fall apart at the end because the right questions were not asked at the beginning. And interestingly enough, we know the old adage that if everything looks like a nail if all you have is a hammer. So, from a technical data science standpoint, we have a lot of tools, very powerful tools at our disposal. If we are given a lot of data, I'm sure we will do all kinds of interesting things with it. But what the bottom line is, we have to drive business value. And to do that, the business teams, the people, the groups that are actually feeling the pains from a business standpoint need to step up, and we need a mechanism for everyone to work together so the right questions are asked. This could be an intersection of business teams coming with problems they are having, and then data teams coming with, hey, we found something interesting, does it make sense for you?
So what is that difference between the approach of data scientists versus business users, and how do you get them on the same page, and what kind of advice can you give in terms of democratizing data science and empowering non-technical colleagues?
Business teams, when they ask questions, they may not, I've seen they don't have to have a filter of, is this an AI problem, right? They have a problem, they come to the table with, here are some issues we are having. So definitely them having some appreciation of how the data science process works is important. Similarly, now we have more specialized roles coming up that are kind of translator type roles. What that means is, you need people who are kind of the bridge between business teams and data science teams that can help translate and validate a problem. Is this an AI problem or not? And then on the other side, whatever the data science team comes up with, how does that translate into metrics that can be measured for business outcomes? So that translation bridge is one way they can work better together. But in terms of democratizing, the more ground level basic literacy that everyone has in an organization about data science, regardless of, you may be a mid-level manager, you may be a operator on the plant floor, or you may be someone selling insurance to end customers. Everyone needs to have a baseline understanding of AI, since it's becoming so fundamentally ingrained in how companies operate, grow, and succeed. So that's done through deliberate education and upskilling that needs to be taken up.
So, as you mentioned, you've been in data science for over a decade, and I understand you come from a control systems background, which was, let's say, historically more reliant on traditional methods of analysis. So, how does data science approach differ from a first principles approach?
Under first principles, you generally have some underlying basis that you already know. These are, let's say, immutable laws of how nature operates. They could be based in physics or chemistry. And then you leverage those fundamental axioms, if you will, to then build models that are still driven by data, but conform to that. They don't violate those principles. So interestingly enough, control systems allow for modeling that is not anchored to some of these first principles, which incidentally is how I got interested in machine learning, because I started getting more and more into these non-parametric models. uh, Handling first principles that's how it's different, where data science is less anchored in a fundamental piece of knowledge that needs to be used. Now both have their place, and they have a role to play in terms of analysis.
Sorry to interrupt there, but are there any moments where you had to put aside some of these kind of these intuitions based on first principles because the data did not support them, and how difficult is it to make, say, such a decision in these kind of situations?
Yes, not so much put aside, but definitely integrate, because you want the best of both worlds. So we have done a lot of work. I've done a lot of work with chemical manufacturers, for example, where in the way we do feature engineering, which is one of the important steps for building models, we take into account what are called as energy balance and mass balance equations, whereby things that go in have to go out. There's no loss of mass energy. Those are taken into account in how features are built. So inherently, those things are factored. So yes, integrating them is most often how they are taken care of. There's also interesting bits which I won't go into. That could be a separate podcast in itself, of physics inspired neural networks and other things that are being worked on to marry both these approaches.
So machine learning provides an opportunity to consider more factors and data. So how do you go about determining what data to use, and what does data collection entail? In particular, there must be challenges with the logistics of it all. So can you shed some light on the process?
Yes. And this definitely goes back. A lot of the challenges here, of course, there are engineering challenges, but there's also, I believe, process related challenges, because when you start solving problems, there's an assumption or an expectation that all of the data is already there, or it's easy to get, which is absolutely not the case. Also, not always business teams know which data is relevant. And some of it, unless you experiment with, you won't know how influential certain data sets are. So one set of problems in this data engineering is setting the right expectations, and the organization as a whole being ready for more agile and experimental kind of mindset. That's one. Second, to that point, is we need processes and environments that allow faster experimentation from an architecture standpoint, the components that are used, so that data can be cleaned, experimented with, and decisions can be made more quickly, as opposed to more waterfall type processes. This is again where there's a lot of uncertainty. Some of the models and data points, there's the good literature in the industry, and there's a good baseline that you can start building things. Then it's more less surprising, I guess.
Most companies have come to appreciate the benefits of building with open source technologies like Python and R. Have you had the same experience, and how do you decide when to build this way versus off-the-shelf software? So in other words, when do you decide to build versus buy?
So me personally, in my experience, for example, I love working with open source. Coming from the technical background and someone who has implemented some of these things, I love the freedom of being able to work with what I can, and not being encumbered by limitations that way. For large organizations, you need to have the right team that can manage this kind of environment, because I won't call it wild west, but it's up to us how we manage governance and maintenance of these open source tools. That's kind of the other side of the coin. But certainly you get a lot of benefit from sticking with open source. On the other side, there are tools that are let's say more off the shelf, which have, it's easier to maintain. Things are kind of abstracted. The thing you have to understand there is, do you have a specific need that it's really fitting in well? And then what is the competitive advantage I'm getting as an organization if that product can be used by anyone else? Is having my data good enough moat to get unique benefits from that product? That's a decision organizations need to make. And one thing I'll say is, build versus buy doesn't have to be a monolithic decision across organizations. Certain problems may benefit from it, certain problems will require customized solutions.
So then how does the proliferation of platforms that allow low code, no code impact this whole build versus buy thing?
In my view, they certainly help bridge some of the gap. I've had experience working in many cases where you still have the ability to insert custom code, and then the low code or no code blocks for things that are more commoditized, you can say. Then within those pieces, management of those pieces in terms of governance and tracking becomes easier. So I think they are good for the industry as a whole to start experiment with low code, no code setups. And then you can, as long as you have processes to have freedom where if I want a custom code in middle of no code blocks, I should be able to do that. So that's a good way to manage, where you can enhance and encourage creativity while also managing risks on for bigger organizations.
Can you give an example of the types of decisions that need to be taken during the model building process and how often business inputs are needed? How important is it to bring domain expertise into the fold while you're building these data science solutions?
Yeah, absolutely. So domain expertise, for example, is very important for validating the results. So a lot of the decisions that are being made while models are built are around how do I treat the data, how do I build features, what kind of assumptions I make to overcome the deficiencies that are there in data, because utility and cleanliness of data is, of course, never a black and white kind of decision. So those decisions, the impact of those decisions on model performance is where domain expertise and business teams are very important. Again, through that translation layer that I mentioned, so that course correction can happen. And when I say course correction, I really believe that a lot of times, we see projects failing because everything is built and then domain experts and business teams are brought in to see the results, whereas that should be integral part of the development process itself. I know that takes up a lot of time from the business teams, but for example, work that I have done, we often encourage every 2 weeks for the business teams or domain experts to actually see what's being built, so that any feedback is incorporated right then and there. They feel part of the solution as opposed to something that's handed to them without them being actively participating.
So you've collected the data, analyzed it, you build a model, you've solved the problem. Now, how do you go about integration and deployment within operations, and what sort of hurdles do you have to overcome?
Yeah, this has become a much bigger topic in the last 3-4 years, I would say, as more and more models are getting productionized, and the modeling itself is becoming, I guess, a bit easier over time. So certainly, things like, does it have to be a real-time model, or is it a periodic predictions or recommendations that are coming out maybe once a day, once a week? That has a big bearing on how the serving infrastructure, model serving infrastructure is built. The outcome can be in a dashboard, or it can be served through automation. So there's integration and tooling that needs to be done, which is often overlooked to be honest, in terms of the time it takes to get value from solutions. So that doing that is very important. And the last piece I'll say is the misconception is that once a model is built, it works well for however long it takes, which is not true. Like we humans, we continue to learn from new information that's presented to us. The same thing needs to happen for AI models. So how to do that in a structured way? That field is called ML ops, and that's become more and more important to incorporate into your process. One last thing I'll say here is some of the decisions around serving are very critical to figure out in the initial stages when you have business and data teams talking to each other. You may have, for example, the best model that you can build in terms of accuracy, but if it takes, for example, 1 minute to serve recommendations on your video streaming platform, no one is going to wait for it. So, requirements of, having real time, let's say predictions versus what model is considered good, they cannot be decoupled. They have to be taken into consideration together to make decisions.
Any parting advice?
So what I will say is, it's definitely, I'm sure everyone has read, things, and like they are hearing the success of AI, and it's not all hype. There is definitely a lot of value in using digital technologies. But if you think you can hire a couple of data scientists, data engineers, and then magic will automatically happen, that's not going to happen. So it is important to embrace it as a whole concept for the entire organization. And then I do see almost every company benefiting from it in some way. So yeah, that would be my advice, is to try to see how you can do this more holistically rather than piecemeal offloading to someone.
Great, Akshay. I look forward to doing this with you again soon.